and a stripe. So in other words, it mirrors and stripes at the same time. RAID 1 plus 0.
Mirrors and stripe at the same time. Could you please
so
explain
stripe, that? Oh, hold on. Alright, so on a RAID 10, a RAID 5, okay, let's just use the 4 here. It'll be the easiest. RAID 5, 1, 2, 3. Okay, all these drives would be used. Drive 4 would be called a parity drive. It would rotate. So in other words, if one drive fails, this one would take over and the RAID would still stay alive. It'd be called degraded, but that's what it's supposed to do until you replace the drive. RAID 1 plus 0 or RAID 10, striped, and then these are mirrored.
Could you repeat?
Stripe, striped, striped, and then mirrored. So it's striped, mirrored. So in other words, we'll only be able to use 12 terabytes. I mean 1.2 terabytes instead of 2.4 terabytes.
Okay.
That we can currently have right now.
When you say stripe, that
meaning that a copy, like this drive will copy to this drive.
Okay, so we will be having replicated data onto this. So just in case one of them fails, this will replace the other one.
Exactly. So in that sense, when you're striping, these two drives act as one. These two drives are mirrored to it. So whatever's on these two drives will have the same exact copy. So now we're going to build it.
So in a way, we are increasing the resources to increase the what? Like increase what? How this would help? Safeguard our data.
Right now, it sees that there's foreign disks. So I had to remove the foreign disk configuration, which it didn't have any because they're brand new drives. Then I had to clear the old configuration that the RAID controller had. Now I'm creating the new RAID. So I'm going to define the RAID here. I'm going to tell it RAID 10. I'm going to tell it to use all the drives. So right now it's saying that we have about roughly 1.1 terabytes, 1.5 terabytes. Advanced settings. I changed my element cache to 256K. We're going to have a read ahead, and we're going to have a write back through.
Okay, element policy. Could you explain me that? What does it mean? The 256 KB.
In other words, it'll pick up chunks of data in 256 at a time and move it over. 256, 256.
Like, is that the fastest?
It's the optimal for our system. Adaptive reading.
That means?
So it'll read ahead if it can. If not, it will not. If we tell it to read ahead without an adaptive read ahead, so it'll automatically read ahead if we tell it to read ahead. Now, adaptive means is that it'll adapt to what its current situation is. If it can read ahead, it will. If not, it will stay where it's supposed to be. So that way, it kind of juggles performance and...
Read ahead, does it mean that...
It will read ahead of itself.
That means
it'll cache the data.
Like, it will put the data in buffer, so that once you execute a command to read the another data, it will have another data in buffer.
Right. So basically, if you have read ahead, I'll have to read up on the termination again, because I'm not 100% sure. But it'll assume that you will want to read the next segment of data and put it in buffer. But if you don't, it's a waste of time and performance. So we do adaptive read, if I remember correctly, that it will try to learn what you're trying to pull the data from at what points, so it'll have it ready for you.
So it will always have something in buffer.
Yes. Okay. So we're going to go ahead and initialize it. And we're not going to configure a hot spare because we only have 4 drives, so so we'd lose performance if we put one as a hot spare. So we're going to tell it it's going to destroy what data is on there, which is fine. There's nothing on it. It's going to build the arrays. Initialized and complete. In other words, we can start the install. And I forgot my disk upstairs. And we're all done. So now I got to go get the disk.
Right.
Yep.